You ever stop and think about sleep? I mean, really think about it? We spend about a third of our entire lives completely out of commission, and for the longest time, nobody really knew why. Well, the answer is way more incredible than you might think, and it has less to do with your brain and everything to do with your metabolism.
So here's the big question, right? Why is sleep totally non-negotiable? We've all heard the usual answers. It's for making memories stick, balancing hormones, or just giving our brain a rest. But that never felt like the whole story, did it? It doesn't explain why, eventually, you literally can't stay awake. So let's just get this out of the way. Forget the idea that sleep is just about a mental reset. The real reason we're forced to sleep is to stop our bodies from having a low-level electrical crisis that's happening inside every single one of our cells. Yeah, it's basically a built-in survival mechanism. Okay, to really wrap our heads around this, we gotta look at why all those old theories just weren't enough. For years, scientists saw what sleep did, but they couldn't nail down exactly why it was so essential. Now, don't get me wrong, all of these things are absolutely happening when we sleep. Your brain cleans house, you lock in memories, your immune system recharges, it's all true. But here's the thing, those are all incredible benefits of sleep, not the fundamental reason our bodies literally force a shutdown. They don't explain that overwhelming biological command to just pass out. The real breakthrough came when scientists started looking smaller, not at the brain as a whole, but at these tiny little engines inside our cells. The smoking gun, it turns out, was hiding inside our mitochondria. We all remember this from biology class, right? Mitochondria are the powerhouses of the cell. But that's kind of like saying a smartphone is just for making calls. Turns out, there's so much more. You should think of them as the cell's command center. They're constantly sensing what's going on and telling the rest of the cell what to do to stay healthy. They're really running the show.
And this is where the trouble begins. See, to make energy, mitochondria are basically zipping electrons down an assembly line at incredible speeds. But the process, well, it's not perfect. It's a bit messy. And some of those high-energy electrons, they inevitably leak out, kind of like sparks flying off a faulty wire.
So what happens to these rogue electrons? Well, they smash into oxygen and create these things called reactive oxygen species, or ROS. You've probably heard of them as free radicals. And these things are nasty. They're highly toxic molecules that literally cause corrosion inside our cells. And the longer we're awake, the more of this electrical damage builds up. And this is not just a theory, folks. Researchers at Oxford actually proved it. They took fruit flies and zeroed in on this tiny group of brain cells that act like a sleep switch. And what they did was incredible. They figured out how to directly control the electron flow in the mitochondria of just those cells. And what did they find? If they made the mitochondria leak more electrons, the flies were forced to sleep longer. If they reduced the leaks, the flies needed less sleep. A direct physical cause and effect. It was a huge discovery. Gero Misenbeck, one of the lead researchers, summed it up perfectly. He said, sleep isn't just a good idea for our health, it might just be the price we pay for using oxygen to make energy. Life wanted the massive power boost you get from breathing oxygen, but the trade-off was mandatory downtime to clean up all the metabolic mess. Okay, so we've established that these electron leaks create sleep pressure. But what makes them worse? This is where it gets really interesting, because it turns out the kind of fuel we're burning makes a huge difference, especially when we're stressed. So, a bioenergetic researcher named Georgy Dinkov has this idea that the system gets totally overloaded when we burn a ton of fat for fuel. Think of what happens during really long cardio sessions or periods of high stress. The process actually uses up a key molecule that acts like a little shuttle for the electrons. When you run out of shuttles, you get a massive electron traffic jam inside the mitochondria. And the result? Way more leaks and a huge spike in those toxic ROS molecules. And there's a double whammy too. When your bloodstream is flooded with all those fatty acids, it actually kicks another molecule called tryptophan loose into your system. So more of this free tryptophan gets into your brain, and what does it turn into? Serotonin. Yep. And as we all know, high levels of serotonin are famous for making you feel tired and sleepy. It's exactly why marathon runners or people on super strict keto diets can feel completely wiped out. Their fuel source is literally cranking up the pressure to sleep. So we've seen the science, we've seen the lab results, but how does all this research on tiny fruit flies actually connect to our everyday lives? Okay, first, let's get a crucial detail out of the way. We humans don't have that simple little on-off sleep switch like fruit flies do. Our brains are, well, they're way more complicated. Our sleep is managed by this whole complex network of different brain regions, all working together. But, and this is the key part, the fundamental principle is almost certainly the same for us. That feeling of sleepiness you get at the end of a long day, that heavy feeling in your eyes, that's very likely the sound of your mitochondria, deep inside your brain cells, sending out a signal that the electrical stress has hit a critical limit. It's time to shut it down for repairs.
And this is where it really hits home. It suggests that conditions like chronic fatigue might not just be in your head, but could actually be a physical problem of inefficient, leaky mitochondria. It gives us a whole new perspective on Alzheimer's because we already know that sleep is when the brain clears out toxic proteins that damage mitochondria. It even explains why people who are sedentary often feel tired. Their mitochondria are just idling inefficiently, creating a constant, low-level mess that needs to be cleaned up.
So if the need for sleep is driven by all this metabolic mess, is there anything we can actually do about it? Can we clean up the system? The answer is a definite yes. Here are 5 ways you can help your cellular engines run a whole lot cleaner.
First, prioritize healthy carbs to give your cells a cleaner, more efficient fuel source and avoid that fat overload problem. Second, maybe dial back the extreme endurance cardio for more moderate exercise that leaves you feeling energized, not drained. Third, use carbs strategically. For example, a piece of fruit after a workout can give your cells that quick, clean fuel they need. And numbers 4 and 5 are huge. Cut out those harmful seed oils you find in so many processed foods and eliminate alcohol. Both of those put a massive strain on your cells.
When you put all this together, it totally reframes how we should think about being tired. Feeling tired isn't a moral failing. It's not a lack of hustle or discipline.
At the end of the day, sleep is just the biological price of admission for living a high-powered, oxygen-breathing life. It's a non-negotiable, protective repair cycle that keeps our internal engines from completely burning out.
And that leaves us with one last thought. Maybe we should stop asking, how can I get by on less sleep, and instead start asking a much more powerful question. How efficiently are my cellular engines running, and what can I do to help them run cleaner? The answer to that, well, it could change everything.